Hi, and welcome to today's lesson on proving triangles congruent. We're going to look at two new methods, the ASA or angle side angle, as well as the angle side. Very similar to our previous postulates, side and side angle side. Now we're just going to use these two, this postulate and theorem, to test for triangle congruence in a different way. So looking at our postulate 4.3, we have here, if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, the triangles are congruent. So if we take a look here, we've got a triangle BAC and triangle EFD. You notice that they both have these congruent angles in A and D, and also you can see that they have congruent angles in E and B. Included in between those angles are these sides. You have segment AB on the one triangle, and you have segment ED on the other triangle, which are considered included sides, and they are in between the two angles, so that makes the two congruent. So let's prove this. Triangle WRL is congruent to triangle EDL using the idea that of the angle side angle postulate. And we also know that L is the midpoint of segment WE. Also, segments WR and segment ED are parallel. So again, we're given that L was the midpoint of WE, and by midpoint theorem we can say that line segment WL is congruent to LE. So going back here, WL would be congruent to LE. Back to our proof, we are given that WR and ED, so those end lines are parallel, and so therefore W and E are alternate interior angles and thus congruent. If we look back, because these two lines are parallel, we can say that this transversal runs through them and makes angle E and angle W congruent. Finally, we know through vertical angle that WLR is congruent to ELD. I think that's pretty. These two angles are equal. We have angle side angle of each that are congruent, so that can find an angle to prove that the two triangles are congruent. And see if you can figure out what is missing in this blank. Alright, so now we have Aas Theorem 4.5 and its proof. If the two angles and the non-included side of a triangle are congruent to corresponding angles of another triangle, then the two triangles are congruent. So as you can see there, angle A and angle B have a non-included side BC. Angle E and angle D have a non-included side EF, and those two angles in a non-included side happen to be congruent. That makes the entire triangle congruent. So to prove that, we come down here and look at the proof. We're given that angle L is congruent to angle Q, angle is congruent to angle R, and MN is congruent to RS. To prove that these two triangles are congruent by our because we know that L and Q are congruent and M and R are congruent, we can use that third angles theorem to show that N and S have to be congruent because they have to add up to 180 if they're a triangle. And therefore, because of we know that these two segments M, N, and RS are congruent, we can use side angle, which we've already proven, to mark that. So it can work to help us prove angle side. So, quick paragraph proof for this triangle. We're given that NAL is congruent to NJM, so we'll make those two congruent. We're also given that KL, this line segment, is congruent to JM, this line, and we want that LN is congruent to MN. So here we have to us this we just said, this we just, and we know that angle N has to equal itself just based on the reflexive property. So therefore, triangle JNM has to be congruent to triangle KNL, since these two triangles are identical by angle side, so angle side. Since congruent parts of a triangle are congruent, we can say that segment LN is congruent with segment MN, because we have those two congruent triangles that we need. Let's go ahead and term in this flow proof. Now looking at a word problem, Barbara designs a paper template for a certain envelope. She designs the top and bottom flaps to be isosceles triangles that have congruent bases and base angles. If EV is 8 centimeters and the height of the isosceles triangle is 3 centimeters, we need to find this segment PO. So again, we know EV is 8 centimeters and the height of the isosceles triangle is 3. So in other words, we'll draw a 3 here to represent that height. Make that perpendicular. So in order to determine the length of PO, we first have to prove that the two triangles are congruent, that we're congruent. By angle side angle, and the definition of an isosceles triangle, though, by the fact that corresponding N and PO have to be equal, because angle side angle, the triangles are congruent and they are congruent parts of that triangle. So then we also know by the transitive property, if we go back here, that NV has to equal PO because it is an isosceles, and L has to equal PO. So now it's 3 centimeters. We can use the Pythagorean theorem to PO. The altitude of the triangle connects to the midpoint of the base. So let's look at that. This height of 3, we know that the midpoint divides this 8 centimeter line in half, so we've got a base of 4. So essentially we've got the hypotenuse here. The hypotenuse squared equals 3 plus 4 squared, so the square root of 3 squared hypotenuse. I should write hypotenuse, get confused with the height, but that's the sine square root of 25, which shows. So this length of each isosceles triangle side, these 4 that we marked out, are all 5s. So now go ahead and check your progress by trying this problem here. Get myself out of the way. So the current tin decorating the window forms 2 triangles at the top. B is the midpoint of AC. AE is 13 inches. CD is 13 inches. BE and BD each use the same amount of material, 17 inches. Which method would you use to prove that triangle ABE is congruent to triangle CBD? So finally, let's just look at a summary of all the things we've discussed in the last 2 videos. When we want to prove triangles congruent, if we know all 3 sides of the corresponding corresponding sides of the triangles are congruent, we can use side, side, side. If we know a side, an angle, and a side are congruent to a side, an angle, and a side of another triangle, we can use side, angle, side. It tells us if an included side between them is congruent to those corresponding parts on another triangle. The triangles are congruent. And finally, angle side tells us we can have two angles in one of each triangle to prove that they are congruent. So that's going to conclude our lesson today. Thanks for watching, and please feel free to let me know if you have any questions. Thanks again.